Everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be jumping into lesson 11.4, the locus of a point. Anytime we get to the locus section, whether it be geometry, pre-calculus, algebra 2, whatever, seems like students kind of like lose their mind all of a sudden. Um, I think it's important to really talk about what is the concept of the locus before we really kind of launch into this, because maybe you didn't understand it in algebra 2, maybe you didn't understand it in geometry class. So let's kind of just go back over it real quick and let's talk about it. Let's kind of reinforce what a locus of points is. A group of points that satisfies a certain condition is called a locus of points, or just simply a locus. Now, this is where I don't really get the disconnect with students many times. Is it's just pretty simple. They give you a set of conditions and you plug in to that set of conditions. Basically, it's like them giving you a line without giving you a line. It's like them giving you a circle without telling you what the circle is. It's them trying to use words to get you to write the equation or to draw the circle or whatever it is. So the locus of points, don't think, oh, this is so hard. No, just think, okay, what are they trying to tell me here? What are they trying to get me to see here? And just kind of write it. Here's some keywords that you can use. When you see the word is, you've been doing this one forever, right? Is means equals in math, always. Greater than, more than, these, keywords for addition. Other keywords for subtraction, like less than, minus, all the words for subtraction. Now, these words might be a little bit more challenging because these are kind of newer. You should have these in the back of your mind. I've been working on these in the last few lessons. But the abscissa is the x point, and the ordinate is the y point. So when you see those words, make sure you just know, okay, that's just the x and the y. That's all they're saying there. The word distance always implies the shortest distance. So in other words, it's not the distance, and maybe if it says the distance around something, it's still talking about the shortest distance around that. The distance through something is talking about the shortest distance through something. The shortest distance between 2 points is always a straight line, right? So you always have straight lines here when you're talking about distance. Distance from a point to a line. So in other words, you're talking about there's a point somewhere. The line segment from the point perpendicular is always the shortest distance between the point and the line. Equidistant from two lines or from 2 points is always a line or a point midway between two others. Again, it's the shortest distance between those 2 points. So you have 2 points here. The shortest distance is the midpoint. Okay? All right. It says that in more complex locus problems, a diagram is helpful. The first step in geometry to me, and even coordinate geometry, is always to draw it. Just draw the graph, write it out, get it on a piece of paper. Even if it's not to scale, sometimes it's just going to help you when you see it in your mind, when you visualize it. All right, so example 1. Find the locus of a point on a Cartesian plane such that the ordinate less than the abscissa is the product of the coordinates. This is where you lose your mind, okay? Because now all of a sudden they're writing it in words instead of writing it in x and y and plus and minus. That's what they want you to do. You have to translate it using this, and there's others. This is not the only one. This is kind of just a small subset of all the words that they're using. But these are some of the key words that you're going to see that should help you decode these sentences that they have. All right, so let's jump over here. And we want to find the locus of points on the Cartesian plane such that the ordinate less than the abscissa is the product of the coordinates. Wow, again, mind blown. So how do we unblow our mind? Well, we take it piece by piece. We do the things that we know how to do. So let's write the basic statement, or let's think through the basic statement. What are they saying? They're saying, okay, find the locus points in Cartesian planes such that this is all worthless right here, okay? You might say, but the locus is important and the Cartesian plane is important. It's not important as far as what they want us to write. This is the important part right here. This is what we need to focus. So let's kind of get rid of this first part and let's write the second part. Such that the ordinate less than the abscissa. Let's use real words. Let's use like real numbers in there. So let's say the ordinate is 3 less than the abscissa. How would you say 3 less than? And now this is, and the abscissa is 5. How do you write in math 3 less than 5? Well, what is 3 less than 5? Well, 3 less than 5 is 2, right? So how would we write that using math? We can't write 3 minus 5 because 3 minus 5 is negative 2. So we have to write, when this happens, this is the one that we have to swap. So we have to say 5 minus 3. That's what equals 2. This is 3 less than 5. So we're going to have a little bit of a swap going on here in the order that our letters are written in. So what is our ordinate? Our ordinate is our y. Our abscissa is our x. This is our less than, but don't forget we have to swap these. So this is going to come out looking like x minus y. There's our magic word is the product of the coordinates. The product of the coordinates. What is the product of the coordinates? The product of the coordinates is, what's the product? Multiply, so we're going to have multiplication. What are the coordinates? We don't know what they are, so it's just x and y. This is done. You're finished. You don't have to do anything else. You might say, well, what else could I do? I mean, you can't do anything because x minus y, you don't know what that is. You could write the x and the y together like that. You're done. Okay, this is all that we can do. We can't really go any farther. We're just writing the equation. All right, next one. Find the locus of points twice as far from the x-axis as the point 0, 3. And again, you might want to sketch this out. So you might want to draw a little sketch, your x and y. Doesn't have to be perfect. Where is point 0, 3? Okay, well, point 0, 3 is 0 on the x and 3 on the y. So we'll just call it like right about here. Okay, so there's 1, there's 2, there's 3. Okay? All right, so what does it say? Find the locus of points. What is the locus of points? The locus of points is going to be a line, it's going to be a circle, it's going to be a square, it's going to be some sort of a shape, a collection of points gives you a line, whether it's a curved or straight line. So you got to be thinking this is going to give us a line somewhere on this graph. And now notice what it says, twice as far from the x-axis. So what we're really looking for is there's going to kind of be some distance going on here. So we have like one distance is going this way. So this is one distance. And the 2 distance is going over here. Because we want a point, so this is going to be our point, and we'll call it point question mark, because we don't know what it is. That you could call that point XY, whatever you want, but I just use question marks right there. So we don't know where that point is. So in other words, like if this distance, so distance, let's say if distance equals 1, then 2 distance is going to, so this 2 distance is going to equal, 2, because it needs to be doubled. What happens if distance equals 2? Then this 2 distance is going to equal 4, and so on. It's just double. So that's the concept. The concept is that this, let me change the color here so you can see it, that this distance right here, the distance from our original point to our unknown point is d for distance. This on the x-axis, this double is going to be double whatever this is. That's the goal. That's what we're going for. So how are we going to accomplish this? Okay, so let's think through this. Let's think through what we need to do. Okay, so as we're building our equation here, you're going to notice that our y, our amount that we're coming off of the x-axis, this number right here is going to be 2d. So it's going to be y, our y coordinate that we're looking for, equals 2d. What's d? D is this distance right here, the distance away from our point that we already have. So that's kind of like the first little section. And so what we need to do now is we need to kind of find what is our distance. Okay? So we need to replace this with the distance formula. So now y equals 2, what is d? D equals the distance formula. X minus x1. So what is x1? Well, this point here was 0, 3, right? This is the one point that we know. So from our one point, our distance is 0 on the x, and that's going to be squared, plus our y point minus 3, because that's the y point that we know, and that is also squared. If you'll solve this, you will come out with your correct answer, or you'll come out with your formula that you need to put. Now, you might say, well, this is done. I'm finished with it because I just put my points into my formula. Yes and no. I mean, technically you do have it, but whenever in algebra or in precalculus or wherever we are, we want to always solve what we can solve. So let's try to solve what we can solve here. What does this give us right here? Okay, well, this gives us, we'd have to FOIL that, right? So x minus 0 times x minus 0. And that's going to give us x squared. And then the outers is going to give us 0x. The inners is going to give us next. So those are going to cancel because it's just 0. And then the last is going to also cancel. So that's just going to give us 0. So this is just going to give us x squared. Now remember, this is all still in the square root sign. And then we'd have a plus, and then we'd have to do this one. So let's go ahead and solve this out. Change the color over here. We're going to go y minus 3, y minus 3. We're going to square that. It's going to give you y squared. And then when we do our outers, we're going to get negative 3 and negative 3. So we're going to get negative 6y in the middle. And then when we square these outers, we're going to get plus 9 right there. So don't forget that that's still y equals 2 times all of this. To simplify this out, we need to get rid of this square root sign. So let's square every term here to get rid of the square root sign. That'll give us y squared equals 4. The square root's going to cancel that, and we're going to get times x squared plus y squared minus 6y plus 9. Now we can distribute this 4 through here, and we're going to end up with y squared equals 4x squared plus 4y squared minus 24y plus 36. All right, and that's about as far as you can go. We can do one more thing, and that would be we can move this over here by subtracting y squared. And that's going to cancel, and that's going to give us 0. This basically sets it up in standard form. So 4x squared, and this is going to give us plus 3y squared minus 24y plus 36. I guess at this point, you could kind of do a couple different things if you wanted to. You could try to factor that to see if there's anything that will factor out. There's no common factors in it, right? So really, there's not much we can do with that. That's probably as simplified as we can get it, and we would just leave it right there. Now, that is, believe it or not, this is something that can be graphed. Okay? How would we graph this? Well, what I would do, and you don't have to do this, I'm just showing you this. I would set up an X and a Y chart, right? and I would say, okay, when y is 0, or when x is 0, what does y equal? Or you could say, when y is 0, what does x equal? And you could solve that, and that would give you something that you can graph. And what this will do is this will show you where that point is, or where the locus of point is on this graph that we came up with up here. Once you do that, it will show you what actually goes there. We just kind of threw something in there, but it will show you actually what goes in there. Okay, let's go ahead and look over at the book, and we'll just take a glance at example number 3. Find the locus of points equidistant from -2 to 3, and the line is x equals -4. Again, this is basically the same idea as using the distance formula. So again, we're just putting our points on there, and then we're talking about as the line x equals -4. So there it is. That's the x equals -4. That's that line. And so how are we going to find this locus of points? Well, to find this locus of points on this one, switch over to the next page. We're going to use the horizontal distance from P to A. And if we go back there, you'll see what that is. So the horizontal distance from P to A, this distance right here, that's what we're looking for. So go ahead and just plug that into the formula, distance formula. Work what you can work again. And then just solve what you can solve. Combine what you can combine. And then the simplest format of this, and notice that they kind of switch this right here. They have the y -3 on the right side. They switch it over to the left side. Why do they do that? Because this is a little bit more of a standard form looking thing. Typically, like slope-intercept is y equals mx plus b. If you write it like this, you have the correct answer. You just kind of wrote it a little bit differently. Example number 4, find the locus of points through 3, 1, having m equals 4. That's the slope right there. What I would do on this one is I would just kind of, put it into the y-intercept form, put it into your formula, m equals tangent of a equals the slope. So just plug into it, and you're going to just kind of put it into, I like it in y-intercept form personally. This is what's called standard form of the line, the 4x minus y equals 13. This is slope-intercept. I like this because I can graph it from right here. So y equals 4x minus 13, but you just kind of plug into it. Work what you can work. You're going to get to a point where because there's an x and a y, you can't go any farther, right? So now you say, how does this give us the locus of points? Well, it gives us the locus of points because if I skip back over here to the computer, you can see what I did was when we get to the end, when we get our equation, we graph it by setting up an x and a y chart, or you just graph it by getting in a slope-intercept or whatever the case may be. But that gives you on your graph, that gives you your line, that gives you your parabola, that gives you your circle, your sine wave, whatever it is that you're graphing. Once you get this, once you write your formula down, once you solve your formula out, you simplify it out, then you can graph it. That's what gives you the locus of points. What is the locus of points? Again, the locus of points is the line that's formed from your equation, okay? It's what you get on the graph. That's the locus of points. So don't be confused by all this. Just do what they're saying. So what they ask you for, plug it into the equation, work it, simplify it, then you can put it onto a graph. Then you can see your locus of points on your graph, okay? I know, fairly complicated lesson. Scroll it back, watch it again if you need to, but work on this. Do some of those exercises, try to figure out what they're telling you to do, and then get your equation so that you can get your locus of points from that equation, okay? That's all I got for you. Have a good one. Bye-bye.